right, welcome back. Welcome back. It is Coffee Break with Microchip. Welcome back to all our regular viewers. Glad to have you back. For those first-time viewers, welcome in. Coffee Break is where we take a few minutes to talk about trending topics and ideas of interest, all in the time it takes to drink a cup of coffee. I hope everybody has their cup poured and is fully caffeinated or about to be fully caffeinated. I got my cup here. We're ready to go. Today's topic is FPGAs, low power FPGAs, and why that power matters, or how that power can affect design decisions. And joining me to, unfortunately not in studio, but live from San Francisco, San Jose, is Avery Williams, one of our product engineers in the FPGA group, and Avery's with us to provide the details today. So welcome in, glad to have you with us.
Man, I'm glad to be here. You know, they told me I was joining Coffee Break, but I actually wanted to join Tea Break. You know, I got my nice hot tea right here with the superior drink. But I guess since there's no tea break, I have to settle for Coffee Break.
So you know, you've missed that conversation in previous episodes. We have gone through that whole idea of coffee, tea, hot chocolate, hot cider, all good. I think the only requirement that we have is that it is a hot beverage and not a cold beverage. That's where we draw the line. So tea is good. Takes a little longer to get ready, but you're good to go.
Then I'll meet that requirement.
You're good. All right. You're allowed to proceed today, so we can continue. Before we get going, let us go to the man at the console, Austin, and Austin, share with our audience how they can participate in the conversation today.
Absolutely. Thank you, Ross. Good morning, Avery, and good morning to our audience. I am looking forward to our discussion today on FPGAs. We are currently broadcasting live on LinkedIn, Facebook, and YouTube. Our experts are standing by in the chat to field our audience questions. And if you're an audience member and you prefer to submit your questions via email, you can do so at livestream@microchip.com. Once again, that's livestream@microchip.com. And also, don't forget to like and subscribe here to our YouTube channel, as well as following our LinkedIn to be the first to know about all things Microchip and Coffee Break. Now, if you tuned into last week's episode, you're likely already up to date on our random giveaway for Ross's nifty liquid containment device. Now, Ross, would you mind modeling that?
Let me demonstrate how it's used like this.
Oh, beautiful! Look at that.
Beautiful.
Utilitarian.
Just like that.
Love it.
Perfect.
Well, what must you do as an audience member to win one of these mugs? Simply click on the link below in our YouTube description, complete the survey, and submit to have a chance to win. Back to you, Ross.
Fantastic. Thanks, Austin. So, Avery, the PolarFire FPGA family was specifically designed with power considerations in mind. So, why don't you walk us through what some of those performance dimensions are, and we can talk along the way as to why those make a difference in designs.
Of course. So the PolarFire, arguably the most awarded FPGA in history. But what warrants all of these awards? Let's start with a discussion we're going to be having mostly today, which is best in power and performance. Now, what makes us a low power leader? It starts off with us being non-volatile and instant on. This is going to lead to low inrush currents and low static power. And that, coupled together with having optimized transceivers, all contributes to the fact that we're going to be 50% lower power than our competitors. Now, that's not all we have. We also have proven security with features like crypto-core processors, built-in anti-tamper, secure boot. These are also just the tip of the iceberg to make sure your design is safe, protected, and secure. Finally, we have reliability. We want to make sure your design is reliable as much as possible in any given situation. So we have SEU immune, and we also have a zero failure in time rate FPGA configuration that makes sure your design doesn't fail while working in radiation or even extended temperature. So with best in power and performance, with proven security and exceptional reliability, this all comes together to make this FPGA family so special.
So when we talk about power, the first place we always start is thermal performance. So why don't you talk a little bit about thermal and how that manifests itself?
Yeah, so let me talk about that thermal aspect a little bit. And I brought these two images, and guys, seeing is believing. Now, these images tell the story in their own right. Now there's two FPGAs, the left one being our PolarFire FPGA and the right one being our undisclosed competitor. They're running the exact same design. And for those that don't know, for a thermal images, red usually means hot and blue usually means cool. And as you
Down at the
can
bottom
see,
corner.
the PolarFire on the left is as cool as can be, and the undisclosed competitor is kind of red hot. So I wanted to also bring the numbers to further back up my statement, which is that we're going to be 50% lower power, which is going to lead to 47% lower temperature, and this is also going to result in a tenth of a fit rate. So also that reliability aspect is secured.
Saw this photo when I first saw this image.
Mhm.
I thought you had taken a picture without the chip in the package or on the board. I mean that's quite a difference between the two. I mean
Of course,
that's startling. That
I
kind
know
of yeah.
it's hard to believe, but trust me, it's real, guys.
Okay, all right. So obviously thermal, the thermal performance leads to other benefits and has other effects on a design. So that heat can be a killer over time. So what does that low power mean, or the low heat thermal
Mhm.
profile mean for the rest of the design?
Yeah. So talking about the fit rate, I kind of mentioned this earlier, but when the fit rate is going to double every time the device goes up, rises in 10 degrees. So what does that mean? That means the temperature junction rises, the more likely the device will fail at a faster point in time. So which could be trouble in thermally challenged environments like ADAS, headlight control, PCLE, backplane controls, and much, much more. So that means that the PolarFire is going to reduce the temperature, and in doing so, reduce the fit rate of your overall design, making sure your FPGA is just added another aspect of reliability.
So, and it's my understanding that a lot of these FPGAs go into systems where it's it's not very easy to get in and replace things. Satellites, for
Exactly.
instance, you get something up there. If it fails, um,
Hmm.
you've got a real
You're in big
problem.
trouble.
Yeah, it's hard to get the repairman up there to fix it.
Exactly.
So what other aspects does the low power lead to in design considerations?
Yeah, of course. So thermal runaway can be a huge problem with SRAM FPGAs, but so as you're seeing on the screen, by using power estimators to sweep the temperature, you can determine when a heat sink is needed for an SRAM. Looking at the graph, the PolarFire being in green and the competitors being in red, I kind of want you guys to focus on the red. And I want you to specifically to look at the delta when the delta T reaches 100 C. Now, why is that important? That's when a heat sink is going to be required. Now, not only will this increase your PoE budget, but it will also make the design much more complex because the FPGA will be moved further from the components it's working in junction with to meet a specific goal. Now, I also brought some more examples of products specific with our PolarFire competing with undisclosed competitors. And the first one's actually going to be our PolarFire SoC. Now, this is with our PolarFire Fabric, but it also has a hardened RISC-V based processor that is designed with real-time processing capabilities in mind. And as you can see, the ambient temperature degrees is we're getting at about 45% lower power, and that is just some of the power savings that you're going to be getting and moving on to our O50 and 100T with the competitors. And I'm just going to be preaching the same story I've been preaching to you guys this entire coffee break. It's going to be 40% to 50% lower power. Now, I don't want you guys to just take my word for it. I want you guys to go and try it out with your own designs. Use our power estimators and plug it in and just see how low power we are. And I want you guys to get that aha moment of, wow, these guys really are low power. And this low power can save me on PoE. This low power can save my thermal constraints. And this low power can save my design in a whole because I won't need a heatsink.
So that estimator is where? Where can they find that tool to go play with?
Yeah, so that's going to be in our powering FPGAs on our microchip webpage, but the link that's on the screen is going to be just our microchip FPGAs. And if you guys click on the link, and I'm sure the moderators are going to be posting this link everywhere in chat, this is going to be a good starting point to go in and really play around with our FPGA portfolio. But we also have the microchip PolarFire FPGAs, and that's the bottom link. And that's kind of what I've been harping on, which is our PolarFire. So please go check out both links. And again, go test it for yourself. Go play. Go put in your designs, go put in your parameters, and just see how low power we are.
So or great thermal performance, high reliability, ease of design or easier design. It's never easy, right? I mean, but easier design because you don't have to have all the heat sinks and other components. And because of that, it's one of the most, if not the most awarded FPGA family out there. So I encourage everybody to go take a look at the resources online, take a look at the tools, take a look at the data that we've got up there, and I think you'll come away convinced that we've got a winner here. So
of course.
With that, I think we will turn to the audience, see if there's any questions. Austin, what do we have from the crowd?
Absolutely. Thanks, Ross. So our first question is coming via email, and that is going to read, how do high-power devices affect board component placement?
Yeah. So I kind of touched on this a little bit earlier, but to elaborate for the question, higher power devices are typically placed near cold walls. With a low power device and no heatsink, you have more freedom and flexibility where you put the component, and it allows you to place a component near other components that are connected to it. And this is especially important when FPGA is working in conjunction with other devices, and it's especially important in devices that require a high pin count device like FPGAs.
Beautiful. Thank you, Avery. We do have another question via email, and that's going to read, how does being instant on affect the design?
Yeah, so to talk a little bit more about being instant on, the first thing that it's really going to do is it's going to simplify your power up sequence, and it's going to require less components than opposing SRAM. And when you have an SRAM that's not instant on, it's going to require complex power leading into inrush current surges, leading to configurational power to get the device to an active state. And while being instant on, that's going to lower your cost, and it's also going to enhance your securing. Why? While reducing initialization time.
Perfect. Thank you, Avery. Well, I'm not sure if you've got time to stick around for one more here for you.
I can stick around one more for you.
Okay, perfect. We have our third via email, and that's going to read, what are the package sizes that the PolarFire FPGAs come in?
Yeah, it's a great question. So our lowers are going to come in 11 by 11 to 16 by 16, guys, and it's a really small form factor package size, and that's going to lead to, again, more flexibility when you're designing and building out your board, because it's going to take up less space, and that minus a heat sink is just going to be able to, enhance your design when you're designing and with that flexibility in mind.
Perfect.
So,
sorry, Ross.
Avery, I'm just curious about package size. Is that smaller than most competitors, or are we able to get things in a little bit smaller package because of the thermal performance, because of some of the other?
Yeah, of course, because of the thermal performance and the low power, and we kind of designed it in mind to kind of bring that power and performance punch in a small form factor, because that one of my favorite things is to walk around with a chipset that kind of shows in like how small our form factor is, and it's just so eye-opening to give to customers and have them look at it and be like, wow, there's no way you can get this FPGA this small, but trust me, guys, we can.
Cool.
Well, gentlemen, I may have spoken too soon. We do have an additional question here from Yassine on LinkedIn, and that's going to read, does the thermal performance depend on the semiconductor used? I think we may have addressed that.
Yeah, kind of addressed it already, but it definitely concerns whatever application you're going to be using the FPGA in, but with the low power, that's going to really lower that thermal performance. So it's going to kind of affect it a little bit more in applications that have extended temperatures and have to be able to have a wider range in temperatures that can be reached. And when thermal is going to be a concern and when power is going to be a concern, that's when you really have to focus on FPGAs that are low power and FPGAs that in turn have low temperatures.
All right. Well, thank you very much, Avery, for taking the time to answer our audience questions. And to our audience, remember to check out the description below for those handy-dandy links, as well as a chance to win that coffee break-themed mug when completing the survey. And if we didn't have a chance to respond to your question during today's episode, make sure to email livestream@microchip.com, and we'll get back to you as soon as possible. And lastly, I do want to remind everyone that they can follow us on LinkedIn to stay up to date on industry trends from our experts here at Microchip. Now to Ross for some closing remarks.
Thank you, Austin. Appreciate that. So this is episode 6 of season 4, I believe. Is that right? I think I'm keeping score, right? I don't have my box score.
Right.
I don't have my box score with me today. But so if you want to watch this episode again, it will be posted on our website, microchip.com/coffee break. You will find this episode. You will find all of the previous 4 seasons. So we are now, I believe, approaching 30 episodes. So there's lots and lots of content there that you can go back and take a look at, and you can go back and review this episode as well. And not only is that the end of this episode, that is actually the end of this season. So this is season 4. We've had 6 episodes. We will be back. I'm happy to say that our contract has been picked up. My contract has been picked up, so I will be gainfully employed for at least another couple months doing this. We will be back, I believe, in mid-October, October 20th, somewhere around there, where we will pick up with 6 new topics. I believe the first one is sensors in harsh environments, featuring the AT Tiny microcontrollers, if my memory serves correct. But lots of great content coming again. Just a quick peek, we will also have our year-end holiday gala of some kind coming, so be on the lookout for that. So that brings us to the end of the episode, the end of the season. Would like to thank everybody involved in this. Austin, thank you for managing everything at the control panel. Sean, David, Kurt, production guys. Always on point, always great. Claudia, who keeps me straight and keeps me going and keeps me organized. And most of all, thanks Avery for joining us today. It's been a pleasure.
Thanks for having me. You guys have been great.
And thanks finally, and most importantly, to the audience out there. Thanks for tuning in. Thanks for coming back. Spread the word. Let people know what's going on. We'd love to have you back for the new season and to start growing the audience even beyond what we have now. So until we see you, I believe October 20th is the next one. Stay safe, stay healthy, stay curious, and keep on learning. And we'll see you soon. Thanks.
Bye, guys.